this is Mr. Miller. Welcome to video 3F. This is on the product rule for derivatives. We're going to see how to find a derivative of a product of functions. So if we have a product of functions f and g and we want their derivative, this is the rule for that. We do f prime times g plus f times g prime. That's how we find the derivative of a product. So we're going to get very used to using that rule. Here are our first two examples. So in this first one, we can think of this as a product of two functions. Negative 5x to the fifth would be function f. And we're going to think of 4x squared minus 1 as function g. And I got the rule over here for the derivative. So y prime, the derivative of this is going to be f prime times g. That's the first term. So f prime would be negative 25x to the fourth times g, 4x squared minus 1, plus the second term is f times g prime, negative 5x to the fifth times the derivative of g, which would be 8x minus 0, which is just 8x, so times 8x. So this was f prime, this was g times g, plus this was f times g prime. Okay, now we can simplify this a little bit. This times that is negative 100 x to the sixth. Negative 25x to the fourth times negative 1 would be plus 25x to the fourth. Here I have negative 40 x to the sixth. So I can combine the x to the sixth terms and I get minus 140 x to the sixth plus 25x to the fourth. All right, if I were you, I'd be saying, what happened? Well, you got to see it a couple times and we'll get the hang of this. So we're just getting started. Here we go. Here's another product. This is f and this is g. So we have f times g, the product of two functions. Here goes the derivative. So y prime equals f prime g. F prime would be the derivative of this, which is 3x squared. And we got to multiply that by function g. Plus, then it goes f g prime. F would be x cubed plus 2. G prime would be the derivative of this, which was 15x squared. So this was f prime g plus f g prime. That's what we have there. We're just applying the rule. Now the rest is algebra. We distribute and combine to whatever we can do. So I'll take care of that. So 15x to the fifth is what you get when you multiply those out. Then 3x squared times 4 is 12x squared. Then over here, x cubed times 15x squared is plus 15x to the fifth. Then we get plus 30x squared. Ran out of room there. So if I combine like terms, I get 15x to the fifth plus another 15 is 30x to the fifth. 12x squared plus 30x squared is 42x squared. There's the derivative. Okay, let's do a couple more examples. All right, so these are very similar. This is f, and this is g. So here goes y prime. It's f prime. The derivative of this is 10x times g, negative 3x squared. All right, plus, and f, that would be this function, times g prime, which is negative 6x, so that's times. All right, so again, what do we have here? F prime times g plus f times g prime. Okay, so if we simplify it, we get negative 30x squared. We get another minus 30, but it's x to the cubed minus 30x. And there's nothing we can do with that. That's simplified. Okay, here we go. this is clearly a product. This is f, this is g. So y prime equals the derivative of f, negative 5x to the fourth times g, plus f times g prime, which would be 6x squared. All right, now distribute and do all that good algebra stuff. So negative 10 x to the 7th minus 25 x to the 4th minus 6 x to the 7th plus 30 x squared. Calculus is very intense in algebra, so we can do this though. Negative 16 x to the 7th. All right, we have that term plus 30x squared. Wow. All right. That's impressive. Okay, now I want to do a couple of kind of different examples. These involve sine and cosine. Okay, in this first example, x squared is the first function and cosine x is the second function. So the derivative, df dx, would be the derivative of the first, 2x, times the second function, cosine x, plus the first function times the derivative of the second, and that's minus sine of x. That's the derivative of cosine. So you can view this rule as saying that derivative of the first times the second plus the first times the derivative of the second. Okay, so I get 2x cosine x minus x squared sine of x. Done. All right, this is the first function. This is the second function there. So it's the derivative of the first, and I need parentheses around that, times the second, plus the first function, times the derivative of the second. Okay, now, if we distributed, there's nothing that can combine. All of these will be times cosine. All of these will be times sine. I'm just going to leave it like that, because really distributing is not going to help any. Now, this one looks like a quotient, and we are going to talk about a quotient rule, but we can rewrite this as x to the minus third times sine of x, and suddenly it becomes a product. All right, so this is the first function, that's the second function. Okay, so f prime, the derivative of the whole thing, is going to be the derivative of the first times the second plus the first function times the derivative of the second, which would be cosine x. All right, now the only thing I can do to simplify is maybe put things with negative exponents in the denominator. So this would be negative 3 sine of x over x to the fourth, plus this one would be cosine of x over x cubed. Wow, this is getting crazy. There's a lot to derivatives. We still got more to go. Okay, time for the journal assignment. So here's the rule again right here. So make use of that. Remember, it's the derivative of the first function times the second plus the first function times the derivative of the second one. Okay, so I think we've done examples like the ones here. Do those in your journal, and we'll see you in class.